Yes. And why? Because you have to explain yourself. Yes isn't enough. Why? Because when I changed the sign on x, I got the same equation, or something like that. It doesn't have to be those exact words. Does anybody have a question about number 1? Okay, so at this point, if I were to ask that question again at another point, everybody would get it right? Number 2, what function is that? Identify it with words or an equation. That's your square root function. That's y equals the square root of x. Number 3 is exactly a question that was on our quiz, a practice quiz one day. What does this mean? Do not get bogged down in the notation. It's very self-explanatory. What does this say? Right here, what does this say? As x approaches infinity, which happens here, right? As x goes to, so as we go to the right, what happens to the curve? It goes up. So we have some kind of behavior like that. We go right and up. What does this say? Left and down. So we got some kind of behavior that looks like that. Right? So think of a function. Again, you've got to have those in your head. Think of those 12 functions. Do any of them start down here and end up here? A line. So some of you said y equals x, right? There's another one I can think of. The cubing function, y equals x cubed, because it starts down here and ends up here, right? So either one of those would have been a perfect answer. Now, every class got a different quiz, so I think, Madeline, I think the quiz you took, oh no, that was still negative, but that, I think maybe was this. Now what changes there then? This is exactly the same, so I'm looking at this kind of behavior. What does this say though? As we go left, it goes up. So that's going to look like that. So now we're talking about a function that behaves like this. Well, can you think of a function that behaves like that? Y equals the absolute value of x, or y equals x squared. We are not confused by end behavior notation. It simply tells us, what does the curve do at the beginning and the end of it? What does it do? Well, here we're going right and up. Here we're going left and up. Okay, number 4. These are not going away. We will spend more time with these because we are going to actually graph them at some point. All we've done so far is kind of list stuff. We haven't really officially graphed it. So we've got to get this under our belts. So I look at this big, massive problem, and what makes sense to start? Factor. So I factor everything. Now, if I factor wrong, then that will mess up all of my answers. So probably it's a good idea, take a stab at factoring and then do a quick check to make sure you've got it factored correctly. This one I can take a 2 out, so I'm left with this. Is that too much all in one? So does everybody see what I did there? Yeah. All right, now what do you notice about it? This does not happen every time, but this time we can cancel. So our problem reduces to now. As soon as you canceled, you should have known, you are going to have a hole. And the hole is a point, and its x-coordinate is always the factor that canceled out. So what value of x canceled out? -1. Now how do you find the y? A bunch of you just stuck 0 in there. You gotta plug it into this right here. You can't plug it in up here, kids. If you plugged it in here, you'd get a 0 in the denominator. Maybe that's what you were doing, I don't know. You can't. You can't ever have a 0 in the denominator, so you gotta plug it in here. So when I plug it in, I get -6 over 2 times -2, which is -6 over -4, which is 3/2. So your whole is at -1, 3/2.
So you switch the sign of the one.
It's what makes it 0. Just like when you put in your asymptote, it's going to be at 1. All right, speaking of asymptotes, we got vertical and horizontal. What's my vertical asymptote? The vertical asymptote is found, and if you don't know this, you make a note of it and you get it learned. Vertical asymptotes are cannot be's. What can x absolutely not be in this problem? 1. So your vertical asymptote is that x equals 1. The vertical and horizontal asymptotes are lines. They should be written as equations. Okay? Horizontal. Y equals 1/2. And you can get that here, or you can get it from the original problem. It doesn't make any difference. The y, or the horizontal asymptote is y equals 1/2. All right, what about the intercepts? We are missing intercepts. Some of us are. And some of us are mixing them up somehow. Don't know how that happens either. How do we find intercepts?
0.
Yep. Intercepts are points. And one of the coordinates is going to be 0, right? Oops, that's right. You want me to publicly humiliate you? Should you be paying attention? All right, so what's what? Well, you know something's going to be 0. Let's not mix these up. Let's take a moment and think. If I am on the y-axis, I'm a y-intercept. That's a y-intercept right there, right? Tell me about that point. That would be 0, 3, right? So if I am on the y-axis, if I'm a y-intercept, then my x-coordinate is 0. Now, I think by this stage of your career, you ought to know that. But if you don't, take the time to figure it out. Don't just guess. So if I want to know what the y-intercept is, I'm going to let x be 0. So I'm going to stick it in right here or right there. It really doesn't matter. It's probably easier here. If I put in 0 here, I get -5 over -2. So what's my y-intercept? 0, 5/2. Now, how about my x-intercept? Well, clearly my y is going to be 0, right? If I'm on the x-axis. So I'm going to let y be 0, so that would be right here. So I'm solving the equation 0 equals x minus 5 over 2 times x minus 1. Some of us are still missing this. You're going to multiply both sides by 2 times x minus 1. What am I going to have over here? 0. What's my x-intercept? See how easy it is when I just do the work? All right, any question about any of those?
So can you not like define that intercepts? Can you not plug it into the original?
You absolutely can. You should get exactly the same answer if you didn't make an arithmetic mistake. Yep, you absolutely can define the intercepts. You can go back to the original. The only problem is you can't find the x-intercept in the original because you canceled one of them out. There technically would be two x-intercepts. No, one's a whole. Yeah, you can't be both. That's why we do our wholes first. Wholes take precedence. Get them out of the problem. Y-intercept do not need that.
What'd you say?
Or you did. Okay, we're going through problem by problem. I'm talking about this problem. Are there any questions on this problem?
I have a question. When determining the y-intercept, does it always apply when it's like the constant at the top or the constant at the bottom?
Now, Maggie, stop a minute. Think about what you just said. How do you find the y-intercept? For what? All the x's. So everything with an x, if you plug a 0 in, it'll automatically disappear, right? So all that will be left are the things that don't have x's. Okay, 5, domain, here we go. Most of us, I think maybe everybody got A right, which is awesome. What's your domain? X is greater than or equal to 3? Oh no, maybe we didn't all get that right. X is greater than or equal to 3. How do we know that? Because what is under the radical has to be positive. Which means x has to be bigger than or equal to 3. Now, what's our second issue with domain? One of them is radicals. What's the other one? Denominators. And what do we know about denominators? Can't be 0, ever, ever, ever. So take a look. Does problem B have a denominator?
Yes.
So x cannot be 0. X cannot be 0. That is your domain. X can't be 0. Now, those of you that, I don't know, did something with -1/5, I see where you got that. You were doing it with the numerator. But wait a minute. When we talk about domain, there are two things we care about. What are those two things? Radicals and denominators. Could I care less what's in the numerator? No, I couldn't care less. Unless it's got a radical in it. Unless it's got a radical in it. I don't care about the top. Unless it's a radical. Because I only care about radicals and denominators. That's all I care about in domain. Got it? Okay. 6, you had to sketch a sine curve. I can't help you. You got to memorize this. You got to memorize it. And it matters how you make your waves, because sines and cosines both have waves. So if you are going to graph a sine curve, you have got to make sure that you started here and that it has a hill here and then a valley. That is a sine curve. I didn't make it up. It's in your book. You're supposed to memorize that. And a cubed, some of you, believe it or not, haven't memorized that either. That's a cubed. That's what a cubed looks like.
A cube type of graph for the origin.
Yes. Unless, remember, we can move things around. So the basic function goes to the origin. If you did this kind of thing, of course, that's going to shift. That's going to shift it. But yes, the basic cube function goes to the origin. Number 7. Okay, so I do this weird shape. What is the domain? All real numbers. Goes forever and ever and ever, all real numbers. What is our range? Greater than y is greater than or equal to -2. Now, a few people said this, and I understand that. I get that. It's a careless kind of mistake. What do you have to pay attention to? Why is this not the answer? Because there's arrows in the picture, right? So there's no ceiling on this. It just has to be bigger than -2. The arrows tell us it goes up forever and ever and ever. Now, the intervals on which you are increasing, What does increasing mean? Where it's going up. Okay, so I want you, right now, if you miss this problem, I want you to put your pencil at the beginning of the curve. It's got this arrow. I want you to put your pencil there, and I just want you to trace over the curve. And I want you to tell me when your pencil starts going up. It isn't going up in the beginning. It's coming down. But then what happens? Doesn't it go up? Okay, so what's this x value right here where it starts going up? What's the x value? -3. That's where it starts going up, is it -3? Where does it stop going up? Okay, the x value. I'm moving left to right, so I'm looking at x values. I start going up at -3. Where do I stop going up? -1. There's your first increasing interval. Those are the x values. We are moving left to right. That is x. So we're looking at the x values. Where is my pencil going up? Starts at -3 up to -1. Now keep tracing. Does it go up anymore? Right here it does, doesn't it? So what x value is that where it starts going up? 3? Where does it stop going up? Never. There's the answer to the question. Those are the intervals over which the curve is considered to be increasing.
Would you put those in brackets or is it just parentheses?
Okay, here's my problem with that. I would take both. I would not mark it wrong.
Okay.
But here's my issue. If I bracketed this, Tom, okay, said, okay, I'm increasing from here to here. Okay, well, what if I'd asked the decreasing question? Well, then I would be decreasing from -infinity to -3, right?
Yeah.
And why wouldn't I bracket that? If I bracketed this, why wouldn't I bracket that? But you can't be decreasing and increasing at the same time. So I prefer to use open parenthesis, or open interval notation, because at that point, you're not really increasing or decreasing, you're stationary. Because it's kind of where it changes from being one to the other. So.
Okay.
All right, so let's go ahead and finish. Let's do the rest of the decreasing. So one of the decreasing would be -infinity to -3. Does everybody understand that? Decreasing. Now where else am I decreasing? Look at x values. Where else is your pencil going down? 0 to 0 to 1. I'm looking at x values. Left to right. X values. From 0 to 1, my pencil is going down. What's happening between -1 and 0? Constant. And between 1 and 3? Not increasing or decreasing. Okay, got it? You haven't taken the quiz yet. Okay? Number 8. What shape are we going to have? A parabola. How do I know it's going to be a parabola? Because it's a squaring function, right? And you probably have memorized anyway, quadratics, graph is parabola. But this is a version of the squaring function, right? Now, what has happened to this squaring function though? It's been moved off the origin. A normal squaring function looks like this. But we have this. So what does this do? Left 1. What does that do? Down 2. So I have the exact same picture moved left 1 and down 2. Right?
Yeah.
Jessica, I don't know what you're doing on that iPad, but I'm getting ready to confiscate it.
Checking my grades.
See, this is the kind of stuff I'm talking about. I'm not singling out anybody. I'm just saying, to be successful, you've got to be committed. You've got to be committed to this. So all the other crap has just got to wait. For your 45 minutes in here, it's just got to wait. Is this thing symmetric across the line y equals x? Well, what do you have to remember in order to answer that question? What? Yeah. What is the test of symmetry across the line y equals x? And what is the test of symmetry? switch the x and the y. So the new equation would become this. Would you agree with that? Now, some of you looked at that and said, oh, nope, they don't match, I'm done. You know what? Be careful. Because if I get y by itself, if I just move this over here and move this over here, what happens? It is the same equation. So what's the answer to the question? Yes. It does have symmetry about that line because when I switch the variables, I end up with the same equation. Emma? Okay, the original problem was this, Emma. So all I do is make this an x and make this a y.
So the negative.
I can't hear you.
The negative doesn't affect it at all.
What do you mean it doesn't? It's part of the problem.
I know, but like since that was an egg.
No, whatever, just put a y on top of the x and an x on top of the y. That's what you do. Then I solved for y so that I could compare my two equations. And when I did that, when I rearranged this new equation, I got the same as the one I started with. Okay. Carter, did you have a pass? Okay. Now, here's what I want to do now. I want you to find, I've given you a bunch of stuff the other day, and I want you to find a paper that says Precal A, period 5 is heart and smile, extra review 1.1 to 1.4. It's on the back of mine. It might be on the back of yours. No. No, it says extra review. Yeah, extra review. It's shrunk, it's got problems on one side and issues on the other side. And it has a heart and a smile at the top. So find the paper that's got a little heart and smile at the top. It's called extra review. It's the back side of the packet, the stapled together packet that I gave you. Well, I don't know if it could be the front side depending on how you're looking at it. It's either the front side or the back side. It's got a little heart and smile at the top. Good for you. Okay. Extra review. Here we go. Domain. We're going to find the domain in problem number 1 for all of these functions. So look at function f. Look at function f. What's the domain of function f? Okay. What about 5/3? I know 5 minus 3x has to be bigger than or equal to 0, right? I'm going to write that down. How do I know that has to be bigger than 0? Because where is it? Under a radical. And if you're under a radical, you got to be bigger than or equal to 0. So now I'm going to solve this. And I'm not going to be freaked out because it's a fraction. I'm a big kid now. I can do this. 5 minus 3x bigger than 0, subtract 5, divide. Remember when you divide though, because I'm dividing by -3, I will have to switch that. So there's part of my domain right there. But what else do I have to worry about in this problem? So x cannot be -2. So there's my domain. If If I were describing that to someone, I would say my domain is everything less than or equal to 5/3 except -2. Boys, let's get our heads up. Let's look alive. We care about this. This is important.
When we write it on like the test, you want us to just write each equation with a
Yes,
comma? and
that's
then-
fine. That's fine. All right, let's look at G. What is the domain of G? X cannot equal what, Jessica? -1/2. Now, how did Jessica know that? She remembers the rule that says whatever is in your denominator cannot be 0. And when you solve that, you get then x can't be -1/2. Do I care about the numerator?
No.
No. Do I care about greater than anything? No. I just can't be 0 in the denominator. How about H? All real numbers. Why is H all real numbers? There's no denominator to worry about, and there's no radical to worry about. And no denominator, no radical means no problem. Right? What about K? X is greater than or equal to -2. Get your head up. This table needs to get more sleep. All right, 2. Even, odd, or neither. Oh, this is a little bit different. This sheet was made quickly. It's got some hieroglyphics in it. So here, let me explain. I've got some function out there. The function, I don't even know what the function is, what the equation is. I don't even know. But I know that if I plug in 4, I get -2. And if I plug in -4, I also get -2. Now, wait a minute. Think about what that means. That means the answer doesn't depend on the sign of the input. So you put in a 4, you get an answer. You put in -4, and you get exactly the same answer. So think about that for a minute. I'm putting in a +4, and I'm putting in a -4. And where would I be putting those in for? X. Those are going in for X, right? So if I'm putting in a -X, and it's not changing my answer, then what, Lane? Oh, yeah, you're writing the equation. And there are tons of equations that would fit this, and that's okay, you can think of it. But what kind of function, would this be odd, even, or neither? Okay, let's back up. Okay, what's the test for symmetry to be odd? Or how do you know you're odd? You change the sign on both X and Y, right? You change the sign on both X and Y. When I look at this ordered pair, this is an ordered pair. What ordered pair would this be? 4, -2. What ordered pair would this be? Okay, did I change the sign on X and Y? Okay, so we're not talking about odd. Oh, wait a minute. I changed the sign on X, and it didn't matter, right? Well, what test of symmetry is that? If you change the sign on X, and it doesn't matter, that's your test of symmetry for the y-axis. So what kind of function do I have? Even, because it didn't matter. Boys and girls, think about this for a second. Think about Lane's example. He said this could be an absolute value function, and it could. Think about, or let me use function notation. What would f of 3 be? What would f of 3 be? 3. What would f of -3 be? 3. F of -3 would not be -3. F of -3 would be 3, right? So look, did it matter whether I put in a positive or a negative? Did it matter? No, No, because the answer came out to be the same. Now, they're talking over there, because they're in tune here, they're thinking, I heard them say, could be squared. Yeah, it could be. What if we had this function? What if you put in 4? What do you get if you put in 4? 16. What do you get if you put in -4? 16. The input sign, the sign of the input doesn't matter in these functions. The sign of the input didn't impact the answer. That means you can change the sign on your x without influencing y. You change your sign on x, you get the same answer. That's the test of symmetry for the y-axis, right? And if I'm symmetric about the y-axis, I am even. So this depicts an even function. Got to think about that one. That's a tough one, for sure. All right, number 3. At your tables, would you do 3? There's 4 parts to it. Would you do part 3? We haven't talked about that together, you and I today, but I want you to do part for number 3 right now at your tables. Everybody's doing the first, second, third, and fourth parts of that. Comparing the answers, and then I'm going to talk about it if we need to. Everybody's doing it.
Do factor.
You guys sort it out. Take a minute, see if you can figure this out.
Yeah, because then you get the answer. It says x minus 1, x minus 1.
But it doesn't say solve.
But no, you can't factor that. So 2.
So you can't factor.
Yeah, you can.
So plug in 1.
Do -4.
I got 4. What do you guys get?
Not 4. Just kidding.
I got 4.
Well, you're doing factoring.
Oh, so you plug in 2 for A, and then plug that into -1. So you're gonna, it's just gonna be 1. This will be 2.
And then you plug 1 away, it's 2. Because, well, you get
It equals 2. Because you get 1, and then you have to plug that 1 into b of x. And 1 squared is 1, plus 1 is 2.
No, it's plus.
and then
What is this little sign?
A, B, you plug B in A. 2.
I don't know if that's right. See, you, I don't know.
Well, 4x minus 6 would be something, right? Wait,
I think you multiply.
yeah, I think you did something like that.
No, no, because of this.
So 4x minus 6 is...
Oh, see where it's right. It's the same. That little circle is the same. So you do, you plug B into, plug B into A.
The answer is,
You plug B into A, right?
A and B, so,
Wait, which one are you
plug B
doing?
into
Are you
A.
guys doing 3 or 4?
4.
Plug B into A.
Not the square root of x.
I can't focus.
2 to x squared minus 1. 2.
I got 2 squared minus 1.
So yeah. And then I can.
Hold on.
Okay, do you have those done? Okay, well, I've got the answers worked out right there, so we can kind of check as we go. For the first one, do you match mine?
No.
Right here. On the paper right in front of you.
I should-
So I got x squared minus 2x plus 4, is that right?
we got negative 2.
The second one, I got 4. For the third one, I got 2. And for the last one, I got 2x squared minus 1. Now, do we need to talk about any of those?
You know how you're subtracting it, just switch the side.
Do we need to talk about any of those?
The minus 2x.
Oh, you're
plus
right.
Third one, b of a of 2. We start by plugging in, we're finding b of a of 2. We're going to find a of 2 first, so what's a of 2? Isn't that 1? Yeah. Then we plug 1 into b, and that gives us our answer, which is 2. Right?
I just did it.
Ooh, okay, it's composition notation. Now, 4 is what we talked about yesterday. You need to be able to understand the question. You understand that you are being asked to find 2 little functions, but when you build them in order, q of p, you get 8x squared plus 5. So what are the operations that have to get accomplished in the problem? If you're going to end up with 8x squared plus 5, you've got to do 3 things. What are the 3 things? Square. Well, let's do it in order. So we're going to square times by 8 and add 5. Right? Now, the first function, which is, we're doing q of p, so the first function will be p, right? What does p have to do? It has to square, right? Now, if you want to, it can also multiply by 8, and then all q has to do is add 5. But you could also, if you wanted, say, okay, p is just going to square. Oops, p is just going to square. So if all p does is square, then what's q going to have to do? Multiply by 8 and add 5. So both of these would be perfectly okay as answers. Number 5, what are you going to do? Your job is to list all the asymptotes and holes, so what are you going to do? You're going to factor everything. What happens if nothing cancels out? Then we don't have any holes, right? We don't have time to finish this, so I'm going to leave that one alone for a second. Make sure you're clear on your homework. Tonight's homework is, you have, I think it's, yeah, it's the opposite, it's the other side. It's the main, it's the, okay. This is the back of my packet, so the front of the packet says Precal A, Chapter 11.1.4, review. It has a heart with a period 5 in the middle of it. It has a heart with a period 5. So your homework for tonight is the review sheet. Listen, if you do the wrong one, you're going to not get credit for it. So please, please, please pay attention. It's the review sheet. At the top, it says Precal A, Chapter 1.1 to 1.4 review, and there's a heart with a period 5 in the middle of it. page of your packet. People, for Pete's sake, it's the front page of the packet.
What did you guys say?
All right. How do you think you're make good decisions?
You have to go by the x's, not the y's. And the other one was square root function.
This?
Yes, Eleanor.
Oh,
wait, oh,
right.
yours is, sorry.
You have zeros in the book. You can miss any quizzes. You need to get in here Monday morning and get them made up. So any quizzes that you have missed that I put in as zeros, you need to get in here and get made up Monday morning. What? You're going to meet in the Water Activity Center lobby at 7:50, which means you'll be here at 7.
Do you need a pencil for the rest of it?
At some point, Anna, you have got to get yourself focused in this class. I mean, it is not stopping, right? So it's time. That's right. So it is time. You can't just miss school. I mean, so I know, you have no choice there. I know that. But you can be here early if your quizzes made up. Sure you don't clean it up that day? Yeah. You can do that. They're only 15 minutes each. Start, how do you expect to be my favorite student?
Yeah, I have everything, and I have maybe quarterback.
Andrew,
Yeah, Andrew, you guys are experiencing it. I think we're good.
It looks really good. It looks good.
Your hair looks like really tight.
Right, just use something different, use different stuff.
Okay.
I use different filters.
Here's the deal. I want you to text your dad, tell him you can't use your phone, but I'm gonna give you your phone back and pay you the detention because, I don't know if I can get it up there by 1:45 when you're leaving. And I won't definitely check your phone when he's at the game. So you text him right now and say, Dad, I am not allowed to use my phone the rest of the day because I do get freaked out. And then if I find out you have that phone out,
Or put it away, right one.
you're not supposed to have that right now.
Oh, not.
No, there is one place on this campus you're allowed to have it. Where is that? SLC.
Good.
Really?
Didn't know that.
Or unless the teacher specifically says, like I told
She's
him,
waiting.
text his dad.
She's waiting.
Because the teacher specifically tells you, get your phones out and Google whatever you're allowed to do.
So you can't have it outside?
You're not supposed to have it out anytime you're in school.
Found this out.
Are we really live?
I found where
Whoa,
Okay, anyway.
what shirt is that?
Tim.
Anybody else have habitat forms that you've got taken care of?
Think Cody will make me
I love
today
everyone
after
talks
this
about
today?
a different job.
Think he'll make me do it today, even though I haven't heard? Because of what happened yesterday.
Okay.
No, I
That's
just.
the reason why.
I did 4 up downs.
I've been working on really slide skills up.
And he said,
You've never seen me bring Rice
he
Krispies.
basically said if you're not gonna go hard, leave.
I give this.
I get your brownie cookies.
I know you're not the first year, but you're not.
No, I didn't. We didn't have any last night. I closed last night. We didn't do
Probably than what I did yesterday.
And I offered you one.
Who's got to have one?
You know, like when you're going down the stairs, I don't know, I wasn't really looking at your guys, so yesterday I went to the dentist. Yeah, like it was like, it was by the bits valve. Like it kind of like bumped it down. I'm like, okay. Smacking the face and like, guys, yeah. So I went to the dentist yesterday, and they gave me 5 numbing shots, but it didn't nerve. So my whole like face, like on this side, went numb, and I couldn't look at it, and I'm still numb. So I'm like trying to get on the side, but I'm in so much pain right now. It's ridiculous. I feel all the shots. Yeah. I'm applying to
That sounded so ratty. That sounded so. It did.
Okay, so when you get office,
I like that.
no, you still have to go through the process.
Yeah, you get to the same.
I just can't.
You get offers. Just like Enos to Santa Barbara right now. Oh, just
Go there. We're gonna take out a.
When we like go over a question though.
Let's do a half sheet of paper.
Before the quiz. Before the quiz. No, I know, but this one, number 12 confused me.
I'm not up.
Those aren't on the quiz? No. Oh, okay. It's tricky. Oh, it's that.
Okay, get out a half sheet of paper.
I'm sorry.
It's probably still running.